Here are a few more examples of different area of triangle problems. So let's say you have an isosceles triangle where the base is 20 and the base angles are 42. So let's draw that out. So the base is 20, so this side right here is going to be 20 units. The base angles are 42, so these are each 42 degrees. So before I even find that vertex angle, we know that we have to find the height in order to find the area, at least at this point. So that creates two right triangles. So these angles each have to be 48 degrees. And this side here gets split in half because those two triangles are congruent by angle, angle, side. So to find the height, we can use either 42 or 48, it doesn't matter, but establish which one you're going to use and then stick to it. So if I use 42, I'm going to use tangent because I'm looking for the opposite leg. So tangent is opposite over adjacent. So h over the adjacent leg, which is 10. Then on my calculator, I'm going to type in the tangent of 42 and cross multiply. So 1 times h is h, and then the tangent of 42 is 0.9004. So when you multiply that by 10, you get 9.00. So we'll just round it to 9. So if the height is 9, the area is base times height divided by 2. Make sure you use the whole base. Sometimes a common mistake is use half the base and then divide by 2. So when you're really just finding the area of half the triangle, alright, we want to find the area of the whole triangle. And we get 90 square units for the area. Just quick PSA, make sure that whenever you're using any type of area formula, it doesn't even have to be triangles, but if you're using a base and a height in a formula, works with triangles, trapezoids, parallelograms, rectangles, the base and the height have to be perpendicular, okay? So like in this case, the base is 17. If that's your base, then 19 has to be the height. Alright, you could theoretically use this as your base, but then this would have to be the height in orange, alright? With obtuse triangles, we learned, and just reminding you that sometimes the base, or the height, is outside the triangle. It's okay. The definition of a height is the distance from a point on your triangle perpendicular to the base or a line containing the base. Okay? So same thing here, like you could, in a right triangle, the legs will just be the base and the height. Or, if you really wanted to, you could make this the base, but then that would have to be the height. So that's perpendicular to that side. Alright? But if you have a right triangle, you should 9 times out of 10 just use the legs to find the area because they're already perpendicular. Okay, so with areas of triangle, when you can't easily find the base and the height, and it's not equilateral, you want to use something called Heron's formula, which we'll talk about in the next slide. So for example, if you had a scalene triangle that looked like this, right? You don't know, there's no right angles necessarily. Looks like that, that's 3, that's 7, that's 9. Alright, none of these sides are perpendicular to each other. You don't know the angles to figure out this height right here. So what do? Well, there's a formula for that. And it's called Heron's formula, and it requires all 3 sides of a triangle. So if you have all 3 sides of a triangle, or if you have enough information to find all 3 sides of a triangle, you should use Heron's formula. I'm getting a phone call from Spam Risk. I don't know anyone named Spam Risk. Should we answer it live on the air? Let's do it. Hello. Hello. Hello.
Hello,
Hello.
this is John, Western Governors University.
Shut up. Bang! Showed him who's boss. Okay. Anyway, I gotta make sure I mute my phone. Okay. Oh, I'm still recording. So there's Heron's formula. Alright, bang, bong, boom. So what do we got? We got S. S is the semi-perimeter. Okay? That's semi, like a semicircle, means half. So it's half the perimeter. So if you know all 3 sides, you add them up and cut it in half. And you plug it in to these 3 parts. And for the side lengths, you plug them in for A, B, and C. So it's the square root of the semi-perimeter times the difference between the semi-perimeter and all 3 sides. So let's try an example. Find the area of a triangle with side lengths, 7, 3, and 9. That sounds familiar. So first thing we're going to do is find the semi-perimeter. So that's half the perimeter. So it's going to be 3 plus 7 plus 9, then divided by 2. So that's going to come out to 19 over 2, or we can round that to 9.5. So our area is going to equal the semi-perimeter, so 9.5 times 9.5 minus 9, so 0.5, times 9.5 minus 7, times 9.5 minus 3. And then just type that into a calculator. Okay, so I typed that in the calculator right here. So I just did the square root button, and then I just typed in 9.5, and then did like times 9.5 times the difference of all the sides, and you get 8.4 is the area. And that would be in square units. Okay, and last thing, so just when would you use 1/2 base times height, and when would you use Heron's formula? So if you want to pause the video and answer these, so you have time to think, now would be a good time to do that. So if you have to find the area of an equilateral triangle given all the side lengths, I would still do 1/2 base times height. It's just splitting it in that one side in half and then using special right triangles to find the height. To find the area of an isosceles triangle given all the sides, I would do the same thing, split it in half, find the height using trig or Pythagorean theorem, especially if you know all the sides. But if it's scalene and you know all the sides, then that's when you should use Heron's formula, because splitting it in half isn't really possible in a scalene triangle. That's it. Hope you feel better about finding areas of triangles and trapezoids.